afternoon, dear students of class 7. Today we are going to learn about atomicity. So atomicity is the number of atoms present in a molecule of an atom of an element. Rather we can write atomicity is equal to number of atoms or molecule of an atom of an element can have. Okay, so atomicity is the number of atoms present in a molecule of an element. Now, this way also we can write atomicity is equal to number of atoms or molecule of an element contain. On the basis of atomicity, molecules can be monoatomic, diatomic, triatomic and polyatomic. Monoatomic, diatomic, triatomic, polyatomic. Now mono means one. Mono means one. So mono means one. Di means two. Tri means three and poly means more than three. Poly means more than three. So, on the basis of atomicity, molecules can be monoatomic, diatomic, triatomic and polyatomic. All metals, noble gases and non-metal, especially carbon. From non-metal, carbon only, are the examples of monoatomic molecules. Now, we'll be seeing which of the elements are monoatomic, diatomic, triatomic. We'll see some examples. Here we'll be writing element. Here we will be writing formula. Here we will be writing number of atoms, or rather you can say atomicity. And here types of. Here we will be writing types of molecule. Types of molecules. Say for example, any element, hydrogen, formula H2. So number of atoms, 2. Number of atoms in a molecule is 2. That means it is diatomic molecule. Then any like iron formula Fe, only one atom, so 1. Number of atom 1. Then it is monoatomic molecule. Again, if I write copper, then Cu formula. Here is only one atom of copper, so one atom, and it is also monoatomic. Then if I have to write helium, formula He. Here also one. So this is also monoatomic, and helium is a noble gas. So all noble gases are monoatomic. All metals, iron, copper, zinc, sodium, potassium, calcium, rubidium, magnesium, all these metals are monoatomic. Hydrogen is a gas, non-metal. So hydrogen is diatomic. Then nitrogen formula N2. Then atomicity, N2 means atomicity is also 2. So this is diatomic. This is diatomic. Then oxygen O2. So this is 2. This is also diatomic. Then fluorine F2. This is also diatomic. Similarly, there are 7 diatomic elements. So there are 3 Zen and 4 I-in. So Zen means hydrogen, oxygen, nitrogen. Fluorine, chlorine, bromine, iodine. These are diatomic molecules, means their molecules have 2 atoms. Their molecules have 2 atoms. Their atomicity is 2. That means they are diatomic. And if I have to write ozone, so it is O3. And atomicity is 3. So this is triatomic. Now ozone, then comes phosphorus P4, and atomicity 4. So this is poly, means it is more than 4. So it is polyatomic molecule. Similarly, if I have to write sulfur, formula S8. So how many atoms are here? 8. So types of molecule, again polyatomic. So I said you all metals, noble gases. So which are the noble gases? Na, argon, xenon, helium, neon, argon, krypton, xenon, radon. All these are noble gases, and all noble gases are monoatomic. They can exist independently in nature. Last class I said they can exist independently in nature in their atomic form. Then these metals exist in the form of atom combining by a metallic bond. So these diatomic elements are the diatomic molecules. They cannot exist in the form of atoms, so they combine with another atom to exist in nature to form molecule. So they are diatomic, and in ozone 3 oxygen atoms combines together to form this molecule. So this is triatomic. Polyatomic, phosphorus molecule has 4 atoms of phosphorus, so its atomicity is 4. Polyatomic molecule. Sulfur atomicity is 8. In a molecule of sulfur, 8 sulfur atoms are combined, joined, so they are also polyatomic molecule. Now hope this atomicity is done. So, what is atomicity? Number of atoms present in a molecule of an element. Number of atoms present in a molecule of an element is atomicity. So I think this is okay. So on the basis of this atomicity, how many types of molecules are there? Monoatomic molecules, diatomic molecules, triatomic molecules and polyatomic molecules. So monoatomic molecules have one atom in their molecule. Diatomic molecules have two atoms in their molecule. Triatomic will have three atoms in their molecule. Then polyatomic will have more than three atoms in their molecule. Now the next point, that is valency. Valency. So what is valency? Combining capacity of an atom. Combining capacity of an atom. Last time I said atoms may or may not exist independently. Atoms may or may not exist independently. Those atoms which exist independently are noble gases. Now rest of the atoms which are not existing independently, they exist in the form of molecule. Now for forming molecule also there is a condition. Say for example, this is hydrogen. And hydrogen has one electron. Now how it will be stable? So in order to exist independently, that is what we call stability. Stability means to exist independently. So in order to exist independently or in order to be stable, hydrogen needs one electron. So this needs one electron, means its combining capacity is 1, hence its valency is 1. So valency is the combining capacity of an element. Now on the basis of hydrogen atom. On the basis of hydrogen atom also we can explain valency. So on the basis of hydrogen atom present in a molecule. On the basis of hydrogen atom present in a molecule, we can talk about its valency. Say for example, NaH. Now in this molecule, sodium hydride. In this molecule, what is this? Sodium hydride. Now in this molecule, how many hydrogens are present? Only one. So valency of hydrogen, I said valency of hydrogen is 1, and this is also called monovalent. I said you the meaning of mono, that is 1. Mono means 1, valent means valency. So whose valency is 1, monovalent. So hydrogen is monovalent, means valency of hydrogen is 1, because it needs one electron to be stable. So the next element to hydrogen, that is helium, which is stable, noble gas. Helium has 2 electrons. So in order to get 2 electrons, hydrogen need only 1. So valency of hydrogen is 1. So NaH, sodium hydroxide, sodium hydride. Sorry, sodium hydride, NaH. Sodium hydride. So valency, from here what we can write? Valency of sodium. Valency of sodium is also 1 because it has one hydrogen. Again, if I write H2O, H2O. Now, this is water, and oxygen is combined with how many hydrogen atoms? 2. How many hydrogen atoms? 2. So, valency of oxygen is 2 because it is combining with 2 hydrogen atoms. Similarly, if I write NH3, now here how many hydrogen atoms are there? 3 hydrogen atoms are present. That means valency, this is ammonia. So valency of nitrogen is 3. Valency of nitrogen is 3. Valency of nitrogen is 3. Similarly, if I write CH4, this is methane. So how many hydrogen atoms are present here with carbon? 4. So valency of carbon is 4. In this way, we can come to know about valency of other elements with the presence of hydrogen atom. How many hydrogen atom is present in the particular molecule? By that also we can come to know about the valency of another element present in that molecule. So NaH, sodium valency 1 because here is 1 hydrogen. In water there are 2 hydrogen atoms, so valency of oxygen is 2. In ammonia there are 3 hydrogen atoms, so valency of nitrogen is 3. In methane there are 4 hydrogen atoms combining with carbon, so valency of carbon is 4. Similarly, on the basis of chlorine also we can explain valency of another element present in the molecule. Valency on the basis of chlorine atom. Also, we can come to know about the valency. So we can define valency on the basis of chlorine molecule also. That means valency of a particular element is the number of chlorine atom present in that particular molecule. So let me draw for chlorine. So this is atomic structure of chlorine, Cl. And in the first cell, what we say, K cell, it has 2 electrons. The second cell, we say L cell, it has 8 electrons. 1, 2, 3, 4, 5, 3, 6, 7, 8. And in the M cell, it has 7 electrons. 6, 7 electrons. So altogether, atomic number of chlorine is 17. Atomic number of chlorine is 17. That means it has 17 electrons in neutral atom. So this has 17 electrons. So we will not go for the electrons that is present in the inner cell. We will go for the outer